So in the last section, we talked about the basics of logging, and we used log4j as an example to show how logging looks like and what the components in the logging classes. And for other logging libraries and even for other programming languages, so the logging framework, logging libraries will be very similar. Okay. Okay. So in this section we talk about modern logging, how people use logging in modern software development, in maintenance and operations. Okay. So overview. So what we do in modern software logging, right? So instead of using a text pattern, some people start to use structure formats such as CSV, JSON, because it's more suitable for machines to automatically analyze the log data. Okay, but people still use a lot of text patterns. That's common because it's easier for human to look at, to examine. Okay. And instead of dump the logs into a file, like what we did in the exercise, right? So nowadays people started to dump logs into a database, right? A database that is capable to handle timestamped events. Okay. So it's easier to search, to index, and to keep this log data. Okay, an example of such a database is Logstash. Um, I remember in the exercise, so our log data is unstructured, right? It's just one line. There's a timestamp, there's a log label, some log message, unstructured. It's very hard for automated analysis. Okay, normally you would use some grep, the regular expression to get the information you want. But think usually in your logging statements, we don't just put text information. Actually, we store some real data. We store the values of the variables, right? Such as the variable of a the value of a runtime variable, or the latency of the query, the size of a file, right? And we want it to be easy to be analyzed, and we want to use automated tools to analyze it. So typically we would use structured logging such as JSON and CSV. Okay. And in old fashion, we use file to store logs. File system is usually robust, but it doesn't scale. You store logs on your local machine. You can only store like hundreds of gigabytes the maximum, right? But log data is usually very large. And if the machine, there's something wrong with the disk, your data would be lost. Okay. And if you don't use a good log rotation strategy, what is log rotation? Basically, your program is generating log messages, more and more log messages. You want to cut your log messages into small chunks, and you want to delete old logs. That is log rotation. You rotate it, today's log, tomorrow's log, and after 30 days, you delete the log data 1 month ago. That's a log rotation. And if you don't do a right log rotation, it will kill your disk, okay? Because log data is usually very large. And it's very hard to search the important information on your local disk. Yeah, this is old-fashioned file logs. People store logs in a local machine. What is a modern style, right? Modern style, previous people started to use something called syslog, or syslog. Is a Unix system log is syslog. So basically, instead of store your log data in your local machine, so you forward your logs into a central machine. The central machine is called an aggregator. So you don't need to worry about your storage of a local machine. Okay. This is one way a modern way is to aggregate all your logs into a search engine. It's not a Google search engine, but it's a search engine for data, for text, for log data. There are lots of tools. So we'll give some examples. Like, so these tools usually support a convenient interface for you to search, to analyze log data. Okay. Some tools such as the Lucene. So here you show Lucene, and I'll give more examples like later. ELK, Splunk. These tools can be used to store, to manage, and to analyze log data. Okay, it's a modern log architecture. The first step to do this analysis, we want to transform the raw logs into some structured data, so that this data can be stored in the search engine or a database to be analyzed later. Okay, how to transform it? We can use some tools such as Logstash. So we put some rules. We give some rules for Logstash, for example, to convert your unstructured data into structured data, right? The rules, some example of the rules can be like the first, for example, the first part before first space is a timestamp, then before second space is a log level, blah, blah. So these rules can be used to analyze, parse the log data into structured ones, okay? Other tools. So you can, if you're interested, so you can do the exercise yourself. There are lots of tutorials about these tools, okay? And there are, most of them are open source. So how we can, typically how we do log analytics or log analysis. So typically, so we will do here, this is a one simple way of one application scenario of log analysis, okay? So when you release a new version of your software, so you want to search the keywords like exception errors in your logs, right? Or like you want to count how many exceptions, how many errors are there, okay? And so you want to get the values of some unique fields. For example, you want to get so how many transactions are successful during a day, right? So you want to get this log. So you want to search for this specific field, get this information, and you want to check the behavior over time. Today there are how many transactions. Tomorrow there are how many transactions. You want to see the behavior over time. And you want to see the traffic patterns over time. Okay, this is just a very simple scenario of log analysis. To summary, we in modern logging, so usually we use a structured format, such as JSON, CSV, and we dump logs to DB, right, to a centralized DB to a location, not on the local machines, right? And we use a DB designed for timestamp data, such as Logstash. Okay, so there are some additional resources you want to check, and I want to. There's another exercise, so we want to do some structure logging. So specifically, ideally we want to set up Logstash, right, to send the log data into a search engine, into a database, and to transfer to structured data. But yeah, it takes time, and it takes maybe several classes, right? So we skip that one. Actually, we do a simple one. We just use CSV, right? So we log information into a CSV file. So what do we do, right? Remember, we set up the Maven, and in addition to Log4j API, Log4j core, here we have a common CSV. So this, because we want to send data into a CSV format, we need a common CSV library. Okay, common CSV dependency, right? Then Log4j configuration. So we need to configure the layout of our appenders, right? We want to configure layout to be CSV instead of a Python layout, right? So if you look at this configuration file, we still have this, for console, we still use this Python layout, so text Python, the one we use. But for file, we have the CSV layout, two types of CSV layout. First one is CSV parameter layout. Second one, CSV log event layout. We will see the difference later. Okay, and we for the root logger, right? So we put everything into these three appenders. And this is how we do, right? This is how we do the coding, use a logger to write logging system statements. So here CSV, we have a verbal values, two ways, right? CSV parameter Python. In this layout, the message in the code will be ignored. It will just print the variables. CSV log event layout will print everything, will print a value 1 equals to a value, value 2 equals to a value, value 3 equals to a value. This is the CSV log event layout. They're different. See the output, right? This is the CSV parameter layout. It would print output like this, CSV file, right? Comma separated values. Okay. For another Python, CSV log event layout, this is output, right? You see, there's some time, right? The log label, the thread, some other, like here we have a log message, value e equals to 10, value 2 equals to 20, value 3 equals to 30, and other information. What information are included in CSV log event layout? Here, this is a table, right? First, we have a time nanos, time meaning, level, thread ID, other information. Okay, there's an exercise. In this exercise, so here you also have a starting code. In the starting code, we already defined how to write the log into a CSV format. You just run the code, it will generate a CSV log file, okay? And what I want you to do, right? So first you should be able to run the code, and you want to make some changes, small changes, like print all logs in Python layout, but only print logs at or above info level in CSV log event layout, right? I want you to configure different levels for different appenders. Some references for you to do the exercise, okay? And because of the time limit, we don't do this in the class. We don't do this after class, okay? If you have any questions, you can still post your questions on Slack, okay? Before we stop this, before we end this class, there's another exercise. If you are interested in, you can do this exercise, okay? This is a log analysis exercise. What is log analysis? Log analysis to analyze the log data, log messages. The first step of log analysis is not parsing usually. Parse unstructured log data into structured log data so that the later steps can use the structured data to do analysis more conveniently, okay? So here, if we look at this example, right? We have a logging statement, it generates a log message. This is a Python layout, right? And what is a parsing, right? Parsing is to get get different components, to separate different components to get a structured data. So in a structure, we know timestamp is this, level is this, component is this, event template, right? So why log parsing is challenging? Because if you see here, like a block, right? Receive block variable. This is a variable. This is not a static text. So from one message to another message, this variable can change, right? For example, here, address, right, also can change. So this, because there are some dynamic variables that can always change. So it's very challenging actually to parse the log data, okay? There are different tools, different open source tools to parse the log data. There are also commercial tools. So here we use examples in a library. Which library we use? So we use this library, log parser. In this library, this is a GitHub project. Within this project, there are multiple log parsers tools supported, such as string, SLCT spell. They are state-of-the-art tools for log parsing, right? And there are some sample log data you want to do the analysis on. And also they provide a Docker image, so you don't need to worry about the dependencies. You don't need to use the Docker image, but if you use the Docker images, it might be easier for you, okay? So what to do, right? First, look at the documentation. Documentation is very clear, just a few steps. There's a demo instructions. Then you check the raw logs to be passed. You get a sense of what a raw logs looks like, and you follow the steps to pass the raw logs and to check the passing results. It's a simple exercise, but can give you a sense of what log analysis looks like. Okay, I that's it. That's it for today. Do you have any questions?